demonstrates in improving information and technology to solve real-world business problems and execute important objectives. And today, he is presenting AMEX credit card default prediction in Kaggle competition. Credit card default prediction is so popular and important topic in the financial domain. He will tell us how he applied the machine learning skills in extremely large data on this topic and advice for Kaggle competition. And just a little bit housekeeping before we get started, please mute yourself during the presentation, and we will have a short Q&A discussion after this section. So now, without further ado, let's applaud the presenter, Mr. Liu, for his presentation. So I will unshare my screen and let our presenter to share his screen, his slide for his presentation.
Okay. Can you see my screen?
Not yet.
Not yet.
It's coming up.
Yeah, now it's
Yes.
coming. Yeah.
Okay, so this is our slides. Can you see the slides?
Yes, we can see it clearly.
All right, just to make sure I'm sharing the right screen here because I have multiple screens here. Well, thanks, Ivy. Thanks, Richard, and for the opportunity to present our work in Kaggler's competition. So thanks, everybody. Take this Saturday night, participate in this discussion. As Richard mentioned and Ivy mentioned, so this American Express default prediction is a very interesting project. So basically, they just want to predict if a customer will default, possibly default in the future. So using machine learning algorithms. All right, so today we're just gonna talk about a few things, and I'm gonna start with the introduction. Basically just a little intro about the competition, American Express default prediction project. And also we're gonna go through data processing, data engineering. This is definitely a big data project. That's a huge volume of data involved. Then we're going to go through a LightGBM model from the tuning, and just touch a little bit of why we're choosing LightGBM model. The next item we're going to discuss feature engineering. So what feature engineering work we have done here. So lastly is lessons learned. This is our first Kaggler project. So we learned quite a lot, and I would like to share with everybody. Okay, so introduction. American Express, probably a lot of people know about American Express, through their credit card issue. So default prediction is very important for risk management and optimize lending decisions. Build a machine learning model to predict credit default with the industry scale data set. Basically, this competition provided a real data. Of course, the data is desensitized. Desensitize the real data. So one intention is they want to improve their production model. So through this project, so that's why they put real data out there. So the goal of this project is to predict the probability that a customer does not pay back their credit card balance amount in the future based on their monthly customer profile. All right, so the data processing, I heard a little bit of echo. Is it okay, Avi?
Yes, yeah, you can keep going. I just unmuted a few new participants.
Okay, I heard a little bit of
Sorry.
echo here. That's all right. So data processing, data engineering, their target binary variable is basically indicator, default or not, is calculated by observing 18-month performance windows after last credit card statement. So each customer has multiple statements. So that basically the aggregated on putting the data set and through that 18-month window, they're just kind of display all the data indicators. If one customer does not pay due amount in 120 days after their latest statement date, it is considered a default. So that means after 120 days of a latest statement, that is considered the customer defaulted his credit card. The data set contains aggregated profile features for each customer at each statement date. The statement include quite a lot of variable features. I would say features include delinquency variables and basically the history of delinquency for the particular customer. Spending variables and a kind of a spending habit for the customer and a payment history, balance data as well as risk variables. So there's multiple statements for each customer, and each statement has all these variables and what we also call the features. And delinquency, spending, payment, balance, as well as risk variables. So there are two data set provided. One is a training data CSV file, as basically is a training data set with 190 features, and there's roughly 16.4 gigabytes. That's quite a large, and as include about 500,000 financial statement. 500,000 customers' financial statements. Tested data set has about roughly the same features, just one feature less, and the size is 33.8 gig. So it's quite a large, and most conventional application just cannot process this data. Also, another label data is provided just for training labels. Well, the environment that we're using use a Kaggle kernel. The Kaggle kernel has certain limitations, like as a memory is 16G. So if your project, your application, go over 16G and just get killed. Even after running, for whole night, after you run 8 to 7 hours, as soon as your memory allocated over 16G, trying to allocate it over 16G, your application get killed, and you lose all the data and everything. So it's running everything. So you have to start from square one. So to get over the memory limitation, we use two techniques. One, we use a Paki dataset. Basically, just Paki is Apache data format, and just for efficient data storage and retrieval. So it uses a column-wise storage. But anyways, it's a really big Apache open source project. It's a Parquet. So you have to first convert the CSV file into Parquet data format to be able to use a Parquet data set. So another technique we're using, we use the FF-based package. Basically, it uses a disk to swap with the memory, swap the data into the memory, and then swap out the data not used in the memory to the disk. So that way it's a little bit slower, but it really can get around this 16G memory limitation. So these two techniques work pretty well, very well. So we never run into issues, data loading issues, data retrieval issues, data processing issues. But we run into the issues, just memory issues when we execute the model, run the model. And then when the model trying to use more memory over 16G, it just killed the application. I think, yeah, these two are really, really helpful to process a large data. Okay, so we're using LightGBM model. So prior to really trying to build a LightGBM, we did quite some research. Also tried some other models, gradient boost models, and we found out LightGBM is better in terms of speed as well as accuracy. So that's why we choose LightGBM model. And I basically built this model, and the parameter tuning is a really repeated process on trying to figure out what are the optimal parameters. So you really don't want to run into the issues, take too long to build the model, run the Kaggle kernel and build a model. And you have to balance the speed and accuracy and overfitting, underfitting. So because every time you run, you're trying to build a model, it takes a lot of, I mean, it takes very, very resources, computation resources. Takes a lot of, yeah, takes quite some time. Every time it's, trying to build a model, it just took 8 or 9 hours, and just totally used up a whole computation time every time. So we're using a boost method Dart for accuracy. Dart is the best, and there's a Goose, JDB. So we found out that Dart is best. So the following, I listed the following parameters and major parameters, and we think are really critical to the model. Like I said, we have to find out the balance between the speed and the accuracy, because computation resource limitation. We only get 10 hours, 9 or 10 hours from the Kaggle to run the application each time. So we really have to think about speed, and have to be, the model builder has to take less than 9 hours to complete. So I just go over briefly the parameters. So the first parameter is a number of leaves, as basically control the complexity of the tree model, on how you want to make how complex you want to make this model. So compare with the gradient boosted tree, the LightGBM as a grow is not horizontally, it's grow just by tree leaves and it goes to a vertical. So it can really kind of build a very, very complex tree. So you have to control it. And also number iterations and just the boosting iteration and the build up your tree. Learning rate combined with number iterations, these two really kind of impact each other to build up your tree, your model. Minimum data in live is really just, you don't want to really consider a lot of specific cases into your, build a lot of specific cases into your model. So that case, you probably can cause the overfitting issues. Feature fraction, and basically, because we have a lot of features, we use about 1,000 variables. So we don't, when we run the model, consider, to speed up and consume less of the resource, and we use a feature fraction. Basically, just use a portion of features, not use. We have 1,000 variables. Just we specify like a 0.8. Just use 80% features. So that just speed up the execution and build up a model, and also use less resources. Bagging fraction. Bagging fraction is just use a portion of the training data set, not use the 100%. So we give a percentage here, just avoid the overfitting. And basically, normally we give a 0.5 or 0.8, use 80% for training data set. So this is called a bagging. And a bagging frequency, just basically for how frequently you want to refresh your sample data. Lambda L2 is really kind of control your overfitting. In the beginning, we're trying to build a model, test our model. We found out, we run into some overfitting issues. So we kind of started using Lambda L2 to reduce overfitting. LightGBM is really control the continuous variables, continuous features bucket. Just group them together. If you have really spread it out, and the algorithm basically build up a certain buckets. And put a range of the continuous data into the buckets. That's just reduce the numbers. We use a 5-4 cross validation to build on the model. Basically, we divide the target label, the data set, into 5 forwards. 1 forward is used for testing, and the 4 forwards are used there to build on the model. So this is a LightGBM. Well, feature engineering. Feature engineering is, I think, is the most important in machine learning. If you want to get a good score, get a good accuracy, feature engineering is absolutely critical. So in this case, in this project, we have 190 features. So we created 1,000 variables on this 190 features. For example, S2 is a spending feature. And we create variables for that feature, like a mean for each customer. Because every customer has multiple statements. Majority customers have like 14, 15 monthly statements. So basically for that S2, that spending feature, we would like to find for each customer the mean for the feature, minimum for that feature, maximum for that feature, standard deviation, and 25 quantiles, 75 quantiles, and a first no empty value, as well as a last no empty value for each customer. So just measure the difference of feature aspects. And also we like to measure the feature value changes. Like, okay, for example, for 15 statements, the mean payment, right? For one variable S2 spending, we can get the mean S2 spending feature. And we like to know the changes. Well, last payment, last payment spending with his mean S2 spending. This is generated different variables. And also we use a visualization to identify variable relations. And we put in the graphics, see if there's any correlation, and if there's any patterns, and we're able to identify these relationships. And basically this feature engineering is a repeated process to identify most appropriate variables. And so you can build up into your model. And also based on the importance of a variable in the previous model, we just remove this less important variables to speed up the execution, the model build. So basically our process is like, all right, once we get a model done, we also get an importance of the variables. What for the 1,000 variables, we look at our scores for each variable, and we just remove the 10% variables, list the important variables. We remove them and we add new variables in. This is kind of a repeated process, kind of also fine-tune process to build up your model and based on the previous model. All right, so lessons learned. This is, like I said, this is our first time use Kaggle. So prior to that, we know nothing about Kaggle. So Kaggle has a lot of limitations. Like memory is a really killer. We run into a lot of issues, and especially building model, process the data, and we let the application run, and after 6-7 hours, they get killed because trying to allocate memory is more than 16 gig. And also speed-wise is very, very slow. Every time we build up a model, so we run into the 10 hours. Like we did our 5-folder cross-validation, right? So we probably can get 2 of them complete. And then we have to go into our code to modify it and continue process. So for 5 cross-validation, we have to kind of have 3 runs of execution. Each run takes about 10 hours. So if you want to complete one model with the features that you selected, take about 30 hours. And I think about it as just for one set of features. So this is a really, really painful process. So it takes a great deal of time and a creative thinking to increase the score just by 0.001, primarily due to memory and execution time. Like I said, our initial score is a 0.790, and we spent like after 6 weeks, 7 weeks, and we can increase the 0.006, and we could have continued to improve, but just during the time, I mean, we really don't have time to get new features and dynamic change features. So that's really just very time consuming, and you build a model with the features with one set of features takes over 30 hours. So that just yeah, it's a lot of time needed to get a good model, training model. So ended up our technical score is a 0.796. After 6 weeks, so we can get a 0.796. So that time we look at it as number one is a 0.80, 0.801. So it's about a 0.005 difference, 0.5% difference. And also found the parameter boundary, like the LightGBM parameters have a lot of parameters. You have to really pay attention to each parameter on the fundamental boundary in the Kaggle. So make sure Kaggle is not gonna kill your application. You have to try one parameter by one parameter and find those boundaries. So make sure your application is not, allocated raw memory. It's a very time consuming, and so our recommendation is if you can just start as early as possible. If you get into the computation seriously, so you really need to get started there, yeah, because it takes a lot of time. Also, check the posting. A lot of people, nice people, posted their suggestions, ideas about the competition. So you can look at how they're doing, what they're doing. If we can get some good ideas to overcome the obstacles and also improve your score, improve your model. Yeah. Well, that's about it. So any questions?
Yeah, we encourage, if you have any question, please just unmute yourself and open your camera to interact with our presenter. Yeah, thank you so much, Mr. Liu, for the presentation.
Sure.
Yeah, so we got some question in the chat box. Joe asks, can we talk about the difference between the XGB and the LightGBM? I think he's mainly more want to talking about the two model applied in this typical topic, like how they perform difference in like your topic.
Expose the, what's the question? I don't see a question on my screen. Can we?
Okay, yeah, it's showing in the chat box. If you can click on the bottom icon of this Zoom, and you can see there's a chat and there's a chat box.
All right, let me take a look. See if I can...
Or
all right, okay, all right, I'll see it. All right, so the first question, it looks quite a parameters were used. How did you tuning them? And what was a major difficult when you choose the most important variables? All right, so the first question, how did you tune them? That's a good question. Well, there are a few ways you can do it. In the Python, you can use some tools to help you to tune the parameters. So you can specify the range, or you can specify your options. You can give multiple values. That led that tool to execute sequentially all options, all the values you selected, and then later on give you the score. So this is a two augmented parameter tuning. So, well, since we're running in the Kaggle environment, so you have to consider the resources in Kaggle, like memory, especially memory issue and the time issue. For example, we tried a parameter. Let me point to this. So we tried linear rate and number iterations. So theoretically, if you give a smaller linear rate, your model is supposed to be more accurate. And if you get a more iteration, and the model can be built with can be optimized and give you a higher score. But if you give a small number linear rate, like a 0.0, we use a 0.05. If you give a very small number, like 0.01, your application will get killed because trying to allocate more memory, the model. So you have a really limitation here when you're tuning them. It's not just like, okay, I want to tune anything. I want to throw in any value. I like to trying to tune the parameter. I mean, well, unless you have a limited resource. So you have some limitation there. So, I mean, that's one thing. And basically you use some augmented tool to help you to tune this parameters. And also after you run some, I mean, you probably can quickly figure out, oh, okay, what is maximum number? I mean, the minimum number I can have for linear rate, or what is the maximum number for my iteration, right? Because your application get cubed. That's a really hard lesson you learn, right? And you gotta have to put down these numbers, and you cannot. This is you set up as your boundary. You cannot cross this boundary, right? That's we said in the lessons learned. You have to really identify these boundaries. So this is how we tune our parameters. So choose the most important variables. So every time we build a model, after model is built, the importance for each variable get listed. That's a very, very long list. Each variable get listed, has a score. So you can rank them from a highest, most important variables to list the important variable. And so basically, since we cannot have more than 1,000 variables, and we have to really dump the 20% list the important variables and add the new variables in. Well, I hope that answered this question.
Oh, thank you very much. Because For the first question, the hyperparameters, if you have quite a few, so it's basically manually to tune it, right?
Yeah, because of the resources issues, and we have to manually tune them. Yeah.
Okay, if you manually do it, so which one you tune first? So this is something. If you tune first and the second one, change, then maybe affect the first one. So in that case, somehow you coordinate how to overall to control all of them. That's my question basically.
Yeah, that's a good question. I mean, like the example I just gave to the learning rate and the number of iterations, they're really kind of work together and correlated and impact on each other. If you give normally for accuracy, you have to give a small learning rate. In our case, the smallest that we can go 0.05, and if lower than that, the Kaggle just queued out application. The largest iteration we go through like 13,000, or sometimes you can go higher. So there are some recommendations, and in the research paper, people experimented those hyperparameters. So yeah, we kind of take some recommendations from this research papers on what is a reasonable number for this model. So yeah.
Thank you, Larry.
All right, sure, no problem.
For the second question, so did you use the kind of PCA or?
Yeah, we use the PCA. We're trying to reduce the dimension. We run into issues. We run into a lot of issues. And go ahead.
Then how do you get calculate the scores for each variable?
Yeah. So ended up we did not, after we tried it many times.
Oh, okay.
Didn't work out very well. Couple of issues there. First, the issue is the current PCA they require no empty data. So you have to, for every data cell, you have to have a value. You cannot have only. If you have only, just throw out. So this is the issue. I mean, that's just bringing the imputation. How you really gonna impute your data, or you're gonna? And we found out for the matrix, and for every customer, but over 80%, 85% the customer has a missing value for one or more. So either we have two choices. Either we have to impute, or we throw them away. If we throw them away, 85% of the data we cannot use. So it's not practical. So we're trying to find trying to get some solutions on the PCA. We eventually get it down to a small data set that we run the PCA and we plug in. Didn't work out very well. Did not work very well. So, and also it's very time consuming, and we didn't have a whole lot of time. We're struggling with the time we have to complete the build up our models, fine tune our models, get a higher score. Another thing we have to figure out a PCA, and we just we eventually give up a PCA. But one thing we learned in the lesson is you really have to, you cannot have to get a very good accuracy on the PCA, you cannot have missing data. Otherwise, yeah, you just cannot run.
All right, thank you very much.
All right. So next question. All right, the difference between the XGBoost and LightGBM. Wow, this is a really big topic. And so, I mean, I'll just give a very brief, you know, what do we got through this competition? In the beginning, we tried to use, you know, we tried XGBoost, and you know, we spent like a week or two initially, and we evaluate to see which one is good. Also, we read a lot of research paper. So for speed-wise and accuracy-wise, and it looks like you know, XGBoost is really just grow your tree horizontally. It has to complete one level for your tree before move down. But LightGBM is not. It's very flexible. It's just really just can grow the vertically, and it give you a lot of flexibility. And based on the research we did, is LightGBM is faster, and also is more accurate. Well, maybe it's because the LightGBM was built after XGBoost, and this guys in the Microsoft, they're probably, you know, picking up a lot of, you know, drawbacks. XGBoost, and they improve it. Did a very good job. All right, so next question. What are the machine learning lift over the benchmark model? Yeah, I mean, my understanding is that traditionally, all this prediction work done by a logistic or, you know, or logistic regressions. Use a logistic regression to predict the probability, right? Give you a numerical number and tell you or what is probability to default. So for big data, I mean, these days people experimented, and if you give a really, you know, on big data can cover, you know, a lot of scenarios, and your machine learning, the algorithm, of course, outperforms logistic regression. I heard the Fannie Mae or Freddie Mac, and they used to use a logistic regression to do a prediction. I mean, they're right now, they all use machine learning. Next question from Dave. What computer did you use to run your model? Your own personal computer with Windows OS or Mac? We use a Kaggle. We use a Kaggle kernel environment. Kaggle kernel environment is free. It provides Python and R. It's very easy to use. But the drawback is you get a memory limitation and execution time limitation. So once you allocate, trying to allocate over 16 G memory, your application will be killed. And also, you cannot run over 9 hours, 10 hours. If you run over 9 hours or 10 hours, your application get killed as well. Well, it looks like Kaggle is backed by Google. And if you want more resources, you can buy from Google. So I guess this is a one way Google trying to promote their business. So you have to pay, like, get a limited memory or a lot of memory, and for a lot of execution time. But you have to pay. All right, next question. Yeah, are you using the GPU? So we did not use GPU. We're trying to, and later on, just we found out as really Kaggle does not support that. So Kaggle support your image processing, all the other stuff provided environment, and kind of use a GPU, all other stuff. And we trying to configure our GPU to run the application. We just failed, and we didn't have time to fix it, and because we have a high priority things to do. So yeah, we tried, we failed to use a GPU. Next question, does Kaggle has enough space to train the big data set? Like I said, a 16 memory, the 16G memory, the limitation, and 9 hours execution time. If you want more, you have to go to Google to buy these resources. Next question, if you do it again, what would you do differently for this big data set? If I do differently, good question. So we're gonna get started as early as possible, because time is really critical in this. I mean, we're doing this pretty much on the sideline. Use or spare time. Yeah, we definitely want to get it started as early as possible. And we're not going to try XGB boost. We're going to probably just directly using LightGBM. We're not going to waste the time on other things. And we're going to try to figure out the boundary for this hyperparameters in the Kaggle environment. Yeah, trying to spend more time trying to improve our score. And I guess the reason we didn't get a really higher score, and we wanted to, just that we don't have time. And we just spent like literally 7 weeks or 8 weeks, maximum 8 weeks on this. We didn't start until after a month this competition started. But actually, I got a message from the WeChat group, and somebody saying, "Oh, okay, and there's a Kaggle competition going on right now, and anybody interested?" So that kind of triggered me look at this project, and we kind of started. All right, we give a shot. So I mean, we just limited the time. If we do it again, probably, and we want to just really cut out the waste. Yeah, and started with the higher priority things. All right, next question. What would you suggest if we can use other sources like AWS SageMaker and Databricks? I'm not quite familiar with the SageMaker, but I know a little bit about Databricks. Actually, we're using the Databricks built on Apache Spark. So it's open source. It's very, very promising, especially you have a big data. It's built on the top of the Hadoop. Use some features of Hadoop, and also has its own features. Improved, get a lot of improvement. It's very easy to use. Provide transformation APIs and function APIs. So it's basically break down the big data into the IDD, and later on, through the API, the Spark assembly them for you, and through the function layer API interface. So, I mean, if you have a big data, Databricks is definitely way to go. Yeah, we're using Apache Spark.
Thank you, Larry.
Sure. Next question, was imbalanced data an issue? Yeah, that's a really good question. We're trying to figure out, I mean, we did a density analysis. There are a lot of imbalanced data there. We trying to deal with it, unbalanced data. What we did. Yeah, we trying to deal with the unbalanced data. The data is very, very unbalanced, and so in the model, so we give the model, say, all right, the data is not balanced. So we specify the parameters. That's one thing we did. Yeah, that's pretty much what we did, and just because of the time, we don't have a whole lot of time to really do this, and we kind of focused on hyperparameters and the feature engineering. That's I think it's most important to improve our score. The reason we use R, well, personally, because myself, because I use a lot of R in the past. I use the Python a little bit, but I feel more comfortable R in this case. And I give a limited time, we literally get 8 weeks. We have to get this project done. So if I could, I'm probably going to use a Python. The reason for that is in the competition, a lot of people use a Python. They share the ideas sometimes, even the code. So probably 80% of people use, or even more, people use a Python. Less people use R. Because I feel comfortable with R. I just pick it up R. I'll see if you can, choose. Python probably is better in this project, and especially machine learning these days is really just kind of a Python dominated. Next question, does your model incorporate social network components? No, we don't. There's no social components here. And as really, dataset is well defined. It's complete. So really, the dataset is all that you need. And you don't need other data. Next question. What is web URL for this project? Can Kaggle, is it possible to see the source code? Yeah, I share the source code. So like I said, because of the execution time limitation, which is 9 hours, we have to build up 2 projects. One project is totally just build up a model. Another project is used to test the model to get a score and submit a file to get the score. So yeah, we shared that. Absolutely, you can look at our source code. I mean, in the WeChat group, Richard, I think I already gave the link, right?
Yes, I think so.
Yeah. Next question. Would you please tell us more details of your feature elimination selection engineering process? Did your feature engineering first on all applicable variables, then throw everything into LightGBM model? Look at the feature importance, eliminate 10% list the important feature. Yeah, like I said, there's a totally 190 features. There are multiple financial statements for each customer. So for each feature, we build up a bunch of variables, like our, the mean, standard deviation, maxima, first, 25% quantile, 75% quantile, just really trying to get it, see which variable works best, be able to really kind of distinguish the default versus no default to the customers. And we ended up with 1,000 variables. There's a lot of variables. So we frequently get into the memory issues because of the model trying to, when they build on the model and they use all the variables, just, memory, trying to allocate in more memory. So later on we reduced, and so our process is like every model we build, and we get this importance of a variable list, and we dump the bottom 10 or 20% list the important variables, and we put in more, new variables, and we run model again. So through that process, somebody speaking? Yeah, okay, that's basically the process, right? We run the model, and we get a model, we get this importance of variable list to get a scores for the importance. We just, drop the 10 or 20% list important variables, and we added a new for next run. Yeah.
Thank you, Larry. Can I just follow up a little bit? So when you say you add in new variables, so those new variables, are you focusing on some of the variables that shows up to be very important, and you add in, you do more feature engineering of it, or are you swapping all your variables? Like you have 1,000 something, you do 800 first, and then eliminate 10-20%, and then put in the 200 that left out.
Yeah, actually, we have more than 1,000 variable. So basically, every time we use about 1,000 variable, probably 940, just to try and do, not trying to get around that memory allocation issue.
Gotcha.
Yeah. So we have a lot of variable. We keep trying different things, and once we get an idea, we generate the new variables, and we dump the list the important, 10% list the important variables from the last model, and then we add new variables in. Yeah, this is a really kind of a repeated process.
Got you. I'm just thinking that when you have so many variables, it's really hard. Even you have the bagging fractions and feature fractions, it's just really hard hard work for the model to select
Oh,
it. It's
you know
highly
what?
coded.
This is a really, I think that's what I mean. You know, I'm thinking really if there's automated two, right? We have two projects. We have to split this project, the whole project into two projects. One is building the model. One is really test the model. You really have to, you know, build a model. You try different things. After that, you have to move all your files into your second project manually. That's a really painful process. Because sometimes the file is big, right? And you have to wait for like 30 minutes, 40 minutes to get the data loaded. And sometimes the process is terminated. You have to start all over again. And so this is really, really painful. You have to manually move the data from one project to another project. You have to import. Yeah, I mean, this is really, I mean, this Kaggle environment is totally unfriendly. And I just, yeah.
Okay, gotcha. Thank you.
Sure, anytime.
Hey, Larry. So it's a great presentation. Thank you for being so generous to present, to share. So I think a few questions. So first, you just mentioned that the initial score you got was 0.790. So what was that initial model looks like?
The initial model is we just use the first set of features we think is good. Second is really we just use this hyperparameters and through our research, and we think you know people just throw some numbers. So you know this initial set of variables and the initial hyperparameter settings. And we get initially we get a kind of a 0.790 score. Yeah.
Okay, so basically you mean without doing anything, people would expect to get something like 0.790. Is that right?
Well, you have to have some basic, like you have to have some basic variables.
Okay.
So we don't really kind of our first set of variables. We generate all of this and we read quite some stuff people posted over there. We generate our first initial set of the variables, and we get a. I'm not sure if you just do nothing, what score you can get. And initially we use like at the beginning we use like 800 and 900 variables. No, we even don't know. I mean, these variables are very relevant. But anyway, yeah. I mean, initially you have to have some basic stuff.
Okay. So then I'm not sure if you are able to look at the champions model and see what is the difference, like whether it's just the timing for you or they have some other ideas, for example, other features, creative features that you don't have.
Be honest with you, I have not get a chance to look it back yet. And
Okay.
I'm just, yeah, once I get some time, definitely, I'm gonna look it back and see, what's the difference. And, especially in the feature engineering and also hyperparameters and, what they use. I'm very interested, yeah.
Okay. I guess another question is that I'm not sure if you have tried some very simple model construction, like use something less than 100 variables, because I'm working as model validation, validator at Fannie Mae. So I've never seen, I've never worked with a model with over 100, features. Mostly like 20 or 30 are the maximum we would keep. So I don't know if you have tried something like much simpler model and see how the performance can.
Yeah, we tried. At one time, we were very, very frustrated with this memory allocation issue. We get a 900, even we reduce the, to 880, and we still get a memory allocation issues. That's when we're trying to tune the hyperparameters. We get so frustrated, so we went to another direction and simplify the variables. We're going to 300, 400, 500, and 600. The performance is not good, really bad.
Oh, really?
Mm-hmm.
Like less
Yeah.
less than 0.790?
Well, it's probably close to initial 790. We have not really gone down. Let me see if we'll get anything below 0.70. Probably not. I have to look at it because we run like we had over 100 scores. Yeah, I probably not. I would say, yeah, we use the 300, 400, 500. I mean, it's a kind of weird. That time we're trying to struggle getting to our 797. Yeah, we just could not. We use this less variables. They're not. Yeah, I mean they cannot meet our expectation.
Okay, so what you said, very bad model, in my opinion, is like as a model validator, if they left from 0.79 to 0.80, which sounds like something immaterial to me, the performance gain. But in the Kaggle, space, it means a lot. I can understand. But in industry, it doesn't make too much difference to me, I think.
Okay.
Yeah.
So, okay.
And also, also another question regarding the model construction is when you do hyperparameter tuning, I'm curious what evaluation metrics you used. Was it AUC directly, or you used mean square error or something else?
No, not AUC. And Kaggle gave special requirements, and is just looking for top 4% and some other parameters. So it does not use AUC, ROC, or any other things on F square, F score, or anything. Is specific requirements to evaluate the score. Yeah.
Okay, so that's the same evaluation metrics you used when you tuned the hyperparameter.
Exactly.
Right?
Yeah.
Okay.
Yeah. We have algorithm there listed there, just really same, exactly, just in line with the project. Yeah.
Okay, I see.
Yeah, it does not use ORC, AUC, all this stuff on the F score. Yeah.
Okay, great. I think that's all the questions I have.
Mm-hmm.
Hey, Larry, this is Lin from. I have a quick question for you. So I'm just curious. In the training data set, the target variable, is a binary variable, right? So either someone is default or not default. So what's the percentage of the people default? So I'm asking this because I was wondering, is there any like imbalanced data issue in this project?
There's an imbalance issue. Oh, yeah, that's right.
So how did you handle the imbalanced data?
Yeah, like I said, we detected an imbalanced data set, and we basically just tell the model use a parameter. I think there's a imbalanced.
Mm-hmm.
Yeah, you can tell. Okay, your data is imbalanced. Just let the model handle it.
Okay. Did you try, for example, reduce some sample from the category which has a, large percentage? Did you try that, or do some data augmentation, something like that?
We discussed a little bit, but like I said, we really don't have time to do this. There are a few things we like to do. Imbalance the data is one thing we really, if we get the time, we really like to address that. And also, another thing is how we're going to really effectively apply the PCA to the data, and we can reduce the dimension so we can get some accuracy. That's another thing we wanted to do, but it just due to time constraint, we didn't get a chance to do it.
Okay. Also, you mentioned that like originally there's like 190 features, and you guys created over maybe around 1,000 variables, right? So you mentioned that you used some visualization to check the correlation between variables. So I was wondering, like since there are 1,000 variables, so how did you visualize those correlations between variables?
Good question. A really good question. So what we did is we take a portion data set, we run the query, we get a portion of the data. We get we get a head, first the head like 5,000 or 10,000. We get a tail, 10,000, 1,000. We get a middle. So we put our own software. We have we develop a software. We have has this visualization feature. Okay. So we just kind of see we can, actually we spend a lot of time on that trying to, identify the correlation and some patterns there. That's if you look at code, we put some actually relation there as well, and it, you find some new variables based on these relations. That's really totally from our visualization. Yeah. Okay. So if you found that there are two variables that are highly correlated, how would you handle that case? Well, basically, we found a few cases, and we put a two-dimensional two variables, right? And we found out that defaulted you can obviously see two clusters. They're separated, right? Then we just kind of developed some formula. Or we said, all right, this is in the far up corner. This is the lower up corner. All right, let's see we get a distance there. We can calculate the square on the distance, and and we can put it in as a relationship. And obviously kind of separate this default and no default customers. Okay. And did you take any measures to handle outliers in your project? Let me see. No, we don't. We detected quite some outliers. Let's see, what do we do with outliers? Yeah, we detected quite some outliers. No, we didn't do anything. So you just let the model itself handle that, right? Well, what we did was, so we derived these variables, right? These variables we derived, we use a mean, we use a max, we use a mean, we use a minimum, we use a standard deviation. Yes. And all of these things, and see we can try to improve this outlier issues. Okay. Yeah, we did not like trying to remove some data points or something like that. No, we don't. We just we derived some variables to do that. Yeah. Okay. Thank you, Larry. All right, sure, no problem.
Hi, Larry. This is Naiyun. Thank you for your presentation. I learned so much. I have a couple of quick questions. First one is, did you use the grid search for hyperparameters tuning for kind of optimal value of hyperparameters? I don't know if R has that function.
Yeah, Python has quite a few. I think optimal. Yeah. So no, I mean, R does not we did not find any for R, but even you can call the Python code from the R, use that Python to use that Python to help you figure out the optimal parameters.
Mhm.
Yeah, I mean Python seems that's another reason I'm saying if you
Right.
could, I mean just use
Mhm.
Python.
Right. So in terms of new features, you mentioned a certain, say, spending level as a ratio of historical average. Have you considered things like comparison with the similar customers, say with a similar credit line, similar history of credit card accounts, something like that? So instead of comparing with the same accounts, historical consistency, comparing with the similar other customers, would that be a potential something variable?
Okay, so all right, just consider the same customer, right? Rather than
Similar, right. Say
same
same.
customer.
Uh-huh.
Oh, so for each variable, like I said, we derive for each feature, totaling 190 feature. So we derive the minimum, maximum, mean, standard deviation, and quantiles, and first no empty value, and the last no empty. Just the first statements. That feature value is not missing, and the last statement, the most recent statement, not
That's
missing.
from their own account, not with any combination of other accounts, right?
Yeah, just the own accounts, not
Right.
not with other people. That's right.
Okay. Yeah, that's fine. So my last question is probably not related to the, I mean, not for Kaggle competition, but more general. For variable selection, do you think running, say, a random forest model and then use that result to help you choose more important features? Would
Yeah,
that
I
be
see
a good
people are
idea
doing
in
that.
general? Okay.
Yeah, I see people are doing that. That basically they even run their ensemble on a multiple algorithm run that give you importance of the variables, and they use that to decide which one you're going to use or not.
Okay, so that's potentially a strategy that
Yeah, that
we
should
can
work.
use.
Yeah,
Okay.
that should help. Yeah.
Okay. Thank you very much. It's very
Sure,
helpful.
sure.
Thanks.
Yeah, I kind of got the impression that a good amount of previous Kaggle winners, they're using stacking model. The final model is stack of a few, boosting model or ensemble models, right? Like random forest, XGBoost, and then LightGBM. And then the final model kind of a stacking of the prediction results from the component models. And then they could possibly win the champion.
Yeah, I mean, see, it's not a practical in a kicker's environment. I mean, I just don't know how long will it take. Yeah, maybe if you have a lot of computer resources, computation resources, yeah, I mean, probably that's a good way to try it and run an ensemble and try different models. Give their importance of variables, and you can decide which one is good or which one is not good. Yeah.
Well, actually, essentially, you are fitting. Let's say you have random forest model, XGBoost model, and a LightGBM, 3 component models. You are training 3 models separately, right? So that's fine. You are not doing them in parallel. You do separately, And then the outputs from the 3 component models could be input to your final, stacking model. The final model could be just a logistic regression model or something, rather simple model to aggregate the results from the component model. That's how, stacking works. So it does not really, it does not really take too much extra, memory.
Okay. Yeah.
And it used to be very common. I'm not sure about these days. Yeah, we do have models at Fannie Mae using the stacking model.
Okay. I see. Yeah, I mean that could that could help. Yeah. I mean, Fannie Mae has a lot of computation resources, computer power. Yeah, you guys can try a lot of things.
Well, that's right. But to clarify, to clarify, you mentioned that Fannie or Freddie possibly have using machine learning model for credit risk. I think there is none, at least in Fannie Mae, because of the regulating. For credit risk models, we're not supposed to use the, so-called machine learning models.
Oh, okay.
Yeah.
Well, what is the concern for regulation? Just not a.
Well, if you have a logistic regression model, the impact of each variable are very transparent, right? Increase something by 1 unit, how the credit risk is going to be increased, right? That's very straightforward to interpret. In a machine learning, black box, so-called black box models, it's kind of not that transparent. That's one thing. And the other thing is that you said in your model you have 900 something variables, and how could you interpret each single variable? That's really hard. So that's basically the reason.
Yeah, I mean, this is cost inference model, so you get a coefficiency explain. I mean, what is our relationship between these variables?
Right, exactly.
I mean, but in machine learning, I mean, as you said, a totally black box. You're right. There's no cost inference.
Well, we know that there could be possibly interactions or non-linear relationship or piecewise linear relationship. In that case, we could use splines, right? Or segmentation, or adding interaction terms to resolve those kind of issues. So that's the best we can do, kind of.
Yeah.
But we do have a good number of machine learning models for different purpose, not really for credit risk prediction.
Yeah.
Hello, Ken, can you hear me?
Yeah.
Hey, yeah, Ken, yeah, thanks. So that is very valuable. We turn to this forum into discussion. So Ken, just curious, when you say they build 3 different type of models and do the stacking, because I think Larry also mentioned not only limited to 16G memory limit, they also need to be limited to the turnover to finish a calculation. So when you stack these 3 things, does the time also add up? Maybe that's break this turnover limit. So Ken, how do you thinking?
I don't think so. I guess the limit is for you to make model inference, right? If you have a stacking model, I don't really think the model inference take that much time. It's just the model training costs a lot of computation resource.
Oh, that way. Got that. Cool. Larry, also want to continue the topic. Seems the Kaggle is very, very valuable to help the data science to sharp their skill. But I also kind of on the same page with Ken is if Kaggle kind of only focus on the accuracy, but does not maybe pay attention to, for example, how many variable or how interpretable, like how easy to interpret that. I just wonder how will American Express kind of leverage the top one model to build for their own business. Because yeah, truly, if that's a financial institution like several banks I work before, never see kind of variable kind of close to 1,000. I don't know, that's kind of beyond this computation. Larry, do you know, or do you get some insights how American enterprise leverage this computation to improve their real business?
Yeah, if you look at the beginning of the competition, American Express put out there. It explicitly said they want to improve the production.
Got
use the outcome of this competition.
That's good. That's kind of interesting. Yeah, Larry, maybe as of participant, you can ask details to this Kaggle computation organizer, see whether they can really use that. So it's kind of a puzzle. I also want to kind of understand. Looks like Ken mentioned the similar things, but that's beyond this like technical details. Regarding technical detail, Larry, can you go to the slides? You talk about what the variable American Express shared. I think one group variable I'm pretty interested. Can you go back to your slides? What variables they have?
Variables.
Oh yeah. So this page, the last Boolean point, the last variable, they call the risk variables. Do you see any detail, like how they define this risk variable? If this risk, so the interesting thing is if they define this risk variable super powerful, maybe they can help you a lot. Or do you see you use a lot of this risk variable when you build your default model?
Well, the variables, they don't give any explanation. Really, they just give a variable names. All right. So all of risk variables started with R. That's really take the first letter of the risk. Like a delinquency variable started with the D.
Okay.
They don't give any explanation or any meaning about our specific individual variable. But they're listed, okay, that variable belongs to which group? I mean, based by looking at the first letter.
Oh, that's the reason when you say spend the variable S2, so that's the second variable in the.
Yeah.
Oh,
yeah.
Got that.
So S2 is one of the spending variable. It's a very important critical variable.
Okay. Just curious, so you do not see any kind of variable from this group, from risk variables in the group. They can be pretty top variable when you build your machine learning model.
Well, there are quite a few R variables there, very important. Yeah.
Okay. Okay.
Yeah, there are quite some variables very important. R risk variables very important.
Okay, cool. Another kind of maybe just the guess. So you say that have a 16G memory limitation. So if you run on your own resource, on your own computer, so if this limit was removed, how much time you can save? Do you have some rough estimation? Or this 16, this is maybe not super important because computation you just cannot bypass that. But when you do your real work, if you think about how much memory you need, so do you have some idea?
You really can go. You can push the boundary very far.
True.
I mean, like some parameters, like I said, as is this learning rate. Learning rate, a lot of people set up extremely low. As a learning rate, you set up a very low, it give you higher accuracy. So in our case, our boundary is 0.05. You cannot go lower. If you go lower, it's just out of memory. Yeah, I mean, if you get a lot of resources out, you can try, because the people recommended learning rate is critical. You should start with that, and also with the number of leaves, and also with the maximum depth of your tree, as well as the maximum bin and all other variables. Yeah, you can try all this, and if you get resources.
Okay. Yeah. Larry, thanks a lot. Yeah, we know we all operate under the real world, under all kind of constraints. So, but this achievement is already great. Yeah, thanks. Back to you, Larry.
Sure, no problem.
Okay, so how time flies. So we have like one more last question in the chat box. That's called the last question. Okay, yeah. So the last question in the chat box is like, did you work on this project alone? If not, how did your team collaborate?
We have a few people on this, but I'm the one primarily work on the Kaggle interface. And people just give ideas and support on their data processing, like this Pokey data format, FF base, all the stuff, ideas from other people. Yeah, I mean, feature engineering, we get other people's support. Yeah, I'm the one actually, anyone, because we're all busy on there. We're doing this on the sideline. So talking about our collaborator, we through the emails, phone calls, if we run into any issues, and we discussed a lot about how we're gonna avoid the memory issue, out of a memory issue. We discussed it a lot. Yeah.
Yeah, thank you so much. Thank you so much, Larry, for the presenting and the question for all the participators. I am sure everyone learned a lot from today's webinar and from your presentation. This webinar was only able to happen because of the hard work from everyone, like our speaker, all the participants, and the CADSEA, of course. If you have any cool project you would like to be interested in sharing in the future, please email us. And thank you very much for listening. We are looking forward to your continued participation in the CADSEA events in the future. See you soon.
Thank
you so much.
Right, thank you,
Thank you, Larry. Great.
Thank you, Larry. Thank you.
Take care.
Thank you.
Have a good night.
Good night.
All right, bye.